Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to another episode of Lost in Science. It is all the science all the time here. Well, at least once a week, I think. Pretty much for half an hour. My name is Chris and Claire is away this week, so it is just me and good old Stu. Stu, how are you?
I'm very well. I've just had some time off myself, but I didn't go as far away as Claire, who's gone all the way to the western side of the country. I did go to the beach and didn't go in because it was too cold. But yes, other than that, I'm very well.
Excellent story there, Stu. And what sort of science have you brought in for us today?
Well, I was going to talk about Australian livestock and how Australia has been riding on the back of Australian livestock for many a long year. And, you know, I mean, I guess that's changing these days, but certainly in the early days of post-colonisation Australia, agriculture was a very important thing. And I'm going to be talking about a form of livestock which probably people don't think of as livestock, which is going to be commemorated by the Australian Mint with their very own $2 coin. But this particular form of livestock also has some problems associated with it, and I'm going to leave it until I tell you in detail what I'm talking about. So see if you can figure out what animal I'm talking about before the story starts, and I might give you a prize or I might not. It just depends how I feel.
No spoilers, Stu. Well, look, I give you more incentive to stick around. I have a story as well, which after Stu I will talk about. It's actually this story is thanks to Stu, so I should credit where it's due. This is some black hole news that you put me onto.
Oh, yeah, so just stealing my story ideas and just running with them.
Yeah, stealing your ideas, yeah.
No, and yeah, I do know what this story is, so there's no mystery there for me, but you tell us exactly what you're going to be talking about. Astronomy
is often in the news. I mean, people like to think about what's going on, look to the stars, never their mind on where they are, what they're doing. But, black holes, I think, are particularly interesting to many people. And in 2020, a possible black hole was identified only about 1,000 light years away, which would have made it the closest black hole to Earth. Now, before you get too alarmed, some new work has thrown some cold water on it. But don't worry, it might not. If it's not a black hole, it could be a vampire. So that's kind of still interesting.
Or a vampire from the black hole. It sounds like a 70s movie to me.
70s or 50s, perhaps.
Yeah.
So I thought I would talk about what all that was, but also just have a bit of talk about black holes in general, because, who doesn't love a bit of a chat about black holes? And I think there are a few misconceptions, maybe, that we might need to clear up about them. So, yeah, that's coming up. So, look, stay tuned for two very gripping stories. On with the show.
Now, if you are old enough, you may remember when Australian currency not only included a $2 note, but it was actually made of paper. You might have a memory good enough to remember what was on that $2 note. Do you remember, Chris?
No, I don't. I know it was green, but I can't remember what on it. Was there a sheep on it, I think?
There was a merino ram on one side. And John MacArthur. Oh, there's always a famous person and something related to their work. So John MacArthur and a merino ram. The other side was William Farrer and a whole bunch of wheat. So it's a very agriculturally oriented currency, that $2 note.
Yeah, I know you'd say, give me some change. I'll have a couple of Wimmers, please. No, we didn't call them Wimmers.
I don't think that. Did they even have a nickname? They were such a small denomination. It was just.
Yeah, I don't think so.
That was just give me the $2. So MacArthur introduced the merino to Australia and helped establish the wool industry. Also contributed to the Rum Rebellion. He was a very, what would you call, a colourful character in early colonial Australia. And Farrer bred a variety of wheat which was resistant to fungal diseases, boosted the grain industry in the early 20th century. And so they were both, for whatever reason, they both ended up on the $2 note, which, considering how much money they contributed to the economy, they should have been on a higher denomination. But no, we ended up with explorers and things on those bigger notes. But the Australian Mint is this year commemorating another important agricultural icon with a newly issued $2 coin that came out this month featuring an important but very tiny kind of livestock. And could you possibly guess what that might be, Chris?
Is it like some sort of miniature cow?
No. It does produce
Okay.
It does produce a very popular breakfast food for some people.
Okay. So is it yeast? It produces Vegemite.
No, it actually is the honeybee. So the honeybee was introduced to Australia from Europe in 1822, which is 200 years ago, and the Mint is commemorating that with a coin. It's a pretty cool looking coin. If you get a chance, you'll probably get one in your change. But I mean, who carries cash these days? But you could Google what the coin looks like. It is a really cool little coin. It's got a honeycomb centre to it. Not an edible honeycomb centre, but it just looks like honeycomb. So the honeybee was introduced in 1822, adapted quickly to the new environment, which meant that people brought over further importations of European honeybees in the following decades. But the first lot came from, I believe, Yugoslavia in 1822.
Okay.
There were indigenous bee species in Australia prior to the European honeybee. The European honeybee is known as Apis mellifera, but presumably the Australian native species have been carrying out the important job of pollinating various crop plants, whatever they happen to be growing up to that point that needed pollination was being pollinated by native pollinators. Now, despite what some memes might have people believe, the absence of the honeybee would probably not result in widespread starvation. And that's due in part to the presence of those other pollinators in many parts of the world, if not most parts of the world, but also because many of our staple food crops, the ones we get most of our calories from, are not pollinated by insects at all, but by wind. So wheat and rice and maize or corn are all grasses, so they are wind-pollinated plants. So we don't really need bees to get our daily calorie intake.
Right, because you're right. This is a very popular meme, and I don't wonder, I'm sure you're going to tell me some controversial stuff, but I don't generally want to diss the bees. I mean, we like bees. And people panic about, say, bee diseases and these sort of things, and saying, as you said, that if bees were to disappear, we would all die. But yeah, it is kind of a bit of an exaggeration, to say the least.
As we can see from the fact that the honeybee was introduced in 1822 in Australia, there were people here before that, and for a long time before
Absolutely,
that.
Yeah.
So, obviously we weren't reliant on the European honeybee. The other staple I was thinking of too was potatoes. They do flower. The potato plant does flower, but it doesn't need to flower to produce the tubers. So there's no bees required to get the spuds either necessarily. The other obvious attraction of the honeybee is their production of honey, which of course they do for their own benefit. They suck up flower nectar and vomit it back up in the hive to feed young bees. And they do also collect pollen from flowers for their own purposes. It's actually a source of protein for bees, is to eat the pollen. But they don't deliberately pollinate flowers. This is just an accident of their food gathering activities. They're just doing their own thing. They're not really there to do that for us. That's just what they do. But obviously, production in many horticultural crops Probably the most obvious ones are fruit trees and various nut trees and things like that. The production levels are greatly increased by the presence of bees. And the apiary industry has over 40,000 beekeepers in Australia who often move their hives around seasonally to improve yields in particular crops. So they just go from place to place in the right season and pretty much rent out their bees to pollinate various things.
And get paid in honey.
The apiarists get paid in cash, and they get the honey to sell later as well. They may also move their hives into areas of natural vegetation at different times to take advantage of the free nectar, which then gets turned into honey that can again be sold for human consumption. And as I said earlier, the honeybee adapted well to the Australian climate, and feral populations appeared pretty much straight away. So queens went out and set up their own hives in various places, and they've spread. And in the last century or so, the number of feral bees in the country has increased quite dramatically. What are the reasons for this? Not exactly sure. Maybe the changing crops. Canola, for example, is a much more widely grown crop than it used to be, which does rely on pollination to get a crop out of it. And maybe that's something to do with the increase in feral populations, but no one's really sure. But due to the relatively short time span bees have been present in Australia, there is some concern from ecologists about their impact on the environment and particularly on indigenous ecosystems. So obviously native pollinators will be in direct competition with introduced bee species for sources of nectar in indigenous and non-native vegetation. But more importantly, not all species are insect pollinated. So there are a lot of flowering plants in which birds and vertebrates, including bats and other small mammals, are important pollinators, and a bee just doesn't do the same job as a bird. So non-insect pollinators are attracted to flowers for the same reason as the bees. The sugary nectar that flowers produce attracts these pollinators, but the arrangement of the nectaries in the flower in relation to the pollen producing and pollen receiving parts of the flower are quite different depending on what the pollinator is.
Right, so they've evolved flowers to suit a particular pollinator.
Yeah.
And then the bees come along, take all the pollen, or for themselves, and there's none left for the actual pollinators.
Yeah, they take all the nectar, and they don't.
The nectar, sorry, yeah.
And they don't necessarily pollinate the flower because they're the wrong.
Right. Okay.
They're the wrong size and shape to get the pollen all over them and spread it onto the next flower. So this is.
Oh no.
This is an issue. So bees can access nectar from flowers without necessarily coming in contact with the pollen or with the receptive part of the flower. So they get the reward with no benefit for the plant directly. Bees also travel relatively short distances from flower to flower compared with something like a bird, for example. So a bird might fly 5, 10, 15 kilometres in a day, which spreads pollen over a very large area. And a bee might only travel a very short distance, which might lead to inbreeding, even if they do pollinate the flowers in some of those species. So you might get these inbred populations of plants where they would have originally had a much broader genetic base sharing pollen over much wider distances depending on what their pollinating species was. But in research published in 2002, and I did find some actual research on the effect of the honeybee in Australia, it was found these effects would vary greatly depending on the plant species, but it would definitely have some impact on evolutionary pressure in native plant species. In other words, the plants will be changed by their reliance on the bees or the effect of the bee on the pollination of the plants. And in some cases, they had higher seed production in these native plants. In some cases, they had lower seed production, but it varied a lot depending on the plant and what the actual situation was. So it seems like with the bees, just as with other introduced livestock which have gone feral, or even livestock that's allowed to forage in natural systems, the ongoing ecological effects of the honeybee are only starting to be studied and understood. And now currently there are 3 species of bees recognised by the Federal Department of Agriculture as invasive species. There is the European honeybee, which is the one which is going to get its little face on the coin.
Right.
The Asian honeybee, which is a completely different species in the same genus as the European honeybee, but that is an invasive species also. And the bumblebee, which doesn't actually do anything for anyone and isn't really a honeybee, it's a solitary bee. And they're only present in Tasmania, but they are...
So they're Tasmania, yeah.
Yeah, they are an invasive species, and they are displacing native bees down there and possibly causing problems with the flowers because they are a lot larger than most other bees, and apparently they damage the flowers as they try and get the nectar out. So this is not a good thing. They bumble around and ruin the flower. But yeah, they, as useful as they are, and as much as we like to look after them for their delicious honey, they are an invasive species, and they do need to be monitored.
That's alarming that we are commemorating an invasive species.
Well, it's odd, isn't it? I thought it was odd myself, considering all of the other coins when they've had animals on them, they've been indigenous animals. It's probably wise to remember that they have some beneficial behaviours, but we should still probably beware they don't cause other problems.
Oh, Stu, thanks for the buzz on that.
I think we're lost.
We're not lost.
Not even any short-range radio signals yet?
Except for a single, very powerful radio emission.
Of course, a transmitter of that sort isn't exactly standard equipment.
Science and technology must be absolutely mind-boggling.
Of course, it's mostly on the theoretical side.
Well, so far.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
All right, yes, you listen to Lost in Science. And as I was saying in the introduction, there was what was believed to be the closest black hole to Earth, which was kind of identified as such, published in 2020. A team from the European Southern Observatory found in a system called HR 6819, which is about 1,000 light years away, they found what they believed to be a black hole. They were looking at the motion of these stars, and they believed it could be only explained by a black hole there. But new work has thrown some doubt on this discovery.
So what they saw, I think, if I understood what I read, was that they were seeing a movement of mass from one star to another, or from one star to another location. Is that what they originally identified?
Well, no, that's what they've, I guess, since theorised is what's happened.
Right.
So what they actually saw was this. They originally when it was first discovered, it was believed to be a single star. But then they were looking at the spectrum of the light emitted, and they found that it had the characteristics of 2 different stars, 2 very similar but different stars. And one of them seemed to be rotating very fast. The other one was rotating much slower. The one that was rotating much slower seemed to be, though, looking at, I guess, effects in the light from it, they could see that it was in a 40-day orbit. So whatever was orbiting was 40 days. The other star, the rapidly rotating one, did not show any signs of such an orbit. So what they said was, okay, so we've got this one star which is orbiting very quickly in a 40-day period. The other one is orbiting on a much wider, longer orbit. And when you've got like 2 stars in the same system but doing completely different things, there's got to be a third object that is causing them to behave this way. And from the calculations, the mass that it worked out to be would have to be a black hole.
And is this because they couldn't see anything else there? So they went, well, there's a big empty space.
Well, it's from the mass and the fact that they couldn't see anything. Yeah, it would have to be an empty space thing. So that's what they concluded. And this is basically, I guess, a story with black holes generally, because they are hard to find because it's in the name. Yeah, let's be honest.
It's not just a clever name.
No. So look, I thought I would have a bit of a look at what is a black hole. which I guess is the good point to start. And probably a lot of people have heard about what an actual black hole is, which is something that has gravity so strong that not even light can escape, which is what makes it black.
Yeah.
So it doesn't give off light.
And there've been the plot of many a science fiction story as well, which often misleads in various directions about what they actually are.
Yeah. Yeah, they're kind of they're usually depicted as some sort of cosmic vacuum cleaner. They just suck up everything around, which is not exactly how they work. It's often been said, like, if our sun was somehow to magically turn into a black hole of the same mass, it would not affect the Earth at all. Well, in terms of orbit, the Earth would not be affected. It would be a lot darker, obviously.
Yeah.
In the daytime. So we would notice, but we wouldn't suddenly get sucked in, because it's the same mass. It's just concentrated in a much denser space.
Yeah. Yeah, I mean, that is one of the things I've seen in films and TV shows and stuff, where a star suddenly, and I'm sure this doesn't happen either, is that a star suddenly turns into a black hole and then for whatever reason gets a stronger gravitational pull, which doesn't actually fit with what they actually do at all.
In some ways, it gets a weaker gravitational pull, because the way that a lot of the black holes, I mean, there are different ways that black holes can form, but I guess the main one we're talking about here are what are so-called stellar black holes, which are black holes that are formed from a pre-existing star. And essentially what happens is the star explodes in a supernova, or I think often with this they call it the hypernova, because it's a particularly big explosion, and what's left behind collapses down into a black hole. So the star has to be above a certain size for all this to happen. So our sun could not actually do this. But you basically need a star that's going to be big enough to have a big enough explosion, and then for the bit that's left over, the core of the star, to be big enough that it's going to collapse down not to a neutron star, which is what most of these turn into, which is kind of a very dense form of matter that's basically just composed of neutrons. But it goes beyond. It's too heavy to be. It goes beyond a neutron star into a black hole. Now, there's been a lot of calculations to work out how big a star would actually need to be. So they you can look at what I suppose is the theoretical maximum size of a neutron star before it will collapse down to a black hole, and the current estimate is around, say, 1.5 to 3 solar masses is kind of the upper limit for a size of a neutron star. But it means the parent star, the star that it came out of, would have been much bigger. It would have been about 20 times the mass of the sun. So you've got stars that are about 20 times the mass of the sun. They explode, and the bit that's left behind, which might be about, say, 2 or 3 times the mass of the sun, will collapse down to be a black hole. So, looking at that way, the remnant, which is the black hole, is smaller than the original star, because a lot of the material's been blown off into space.
Yeah.
And so, in that sense, the black hole actually has less gravity, if you want to look at it that way.
And also, because it's smaller, wouldn't the distance affect the gravitational pull? If you were at a set distance away from the black hole when it formed, would the gravitational pull be weaker on you because you were further away because the object was smaller? Does that make sense?
No, because you calculate from the centre of mass.
Okay. All right.
of the object. I mean, look, let's be honest. In this circumstance, if you're standing next to a supernova, probably the black hole is the least of your worries. And this is the actual interesting thing. Like, we're talking about, people go, oh, there's a black hole 1,000 light years away. Should we be worried? Obviously not. It's not going to come and suck us up. If there was a supernova 1,000 light years away, then potentially we could get like a lot of radiation from that. Opinions differ on the effect of a supernova and how close it would have to be for us to feel the effects of it. But that's kind of a much bigger deal. A massive explosion like that is a much bigger deal than just a black hole sitting there.
Yeah.
But yeah, so look, because they're black, they are fairly difficult to detect. We have, of course, recently been able to detect them. There's new developments. In 2019, there was a famous photo taken of the black hole in the center of another galaxy. That was a supermassive black hole that is so big that you can actually see it from that far away. But you're not seeing the black hole. You're seeing the stuff that's falling into the black hole in that case. When black holes if there's enough mass around them for them to drag it in, then as it falls in, it heats up, it gives off X-rays. They're very powerful X-ray sources.
So we're not seeing the plug hole. We're seeing the water draining into the plug hole.
Exactly. We also have now the ability to detect gravitational waves, and we detect, the echoes, the ripples through space put off by collisions between black holes. And we can even see the gravitational effects of a black hole when it, say, passes in front of another star. This is called microlensing. You can basically see things just through their gravitational effect alone as they distort the background light. So there are various ways that we can actually detect black holes, but a lot of it is still this kind of calculation, as happened with this one. And a lot of these discoveries are kind of controversial because you have to deduce what's going on. So like I said, in this case, they deduced that there had to be a third object, which could only really be a black hole that fit the criteria. But a different team put forward a different theory, saying that no, in fact, there doesn't need to be a third object. We could do this with only 2 stars. And so the two teams, instead of arguing about this, they actually decided to work together and pool their resources and their instruments. And they recently, in March, they published a joint paper in the journal Astronomy and Astrophysics with their results, which basically said, oh yes, it looks like it is just the 2-star system. So essentially what's happened here is that one of the stars, as you said, has sort of sucked off some mass from the other star. They look very similar still because they were the same kind of star to begin with, but one has since become a vampire, sucked off a lot of material from its companion, and that's caused it to rotate a lot faster because it has suddenly gained all this extra mass. But they're still the same kind of star. Now they just have different masses, and so they look different. But the conclusion is that it is only these 2 stars that are orbiting in this 40-day period. So yeah, it's kind of a different situation, but it's kind of an exciting one because this is only kind of a short-lived period of time that this kind of thing happens. This has just happened that this star has sucked off all this material, so we get to see what this kind of system looks like in this circumstance and look at where it might go next. So it actually is quite an interesting discovery in that sense, because there is stuff happening. This is like a dynamic system with changes going on, and we can watch it as it happens. It just is not a black hole as is the most likely possibility. I kind of had a look at what the other candidates for closest black holes are. The next closest one on the list, according to Wikipedia, is 1,500 light years away. But recent data suggests that it might not be a black hole either. So you kind of got to work your way down the list before things get really, I guess, certain. So yeah, we know they're out there, but they are hard to find. But look, if they're longer than 1,000 light years away, again, you don't really need to be worried.
Well, I'll rest easy now.
And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook, we're Lost in Science on 3CR, or on Twitter, where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now, where at the same time every week, Claire, Stu and Chris get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.